Now I'll outline the question, outline the solution when n belongs to odd. When n belongs to odd, we have 1 plus x2, maximum of this one, maximum 1 plus x2 mod, x2 plus x3 mod, comma x3 plus 1 ka mod is greater than or equal to Tn. This is what the question says, right? Now, so what we try to do here is, first of all, our thought process goes that again this could be 0, Tn could be 0. So in case we try to work that out, we put this as 1, then minus 1, then maybe minus 1 and 1. The problem here is that doesn't work here, right? We cannot simultaneously make all of them 0. So Tn being 0 doesn't work. There we do not find case where actually all of them become 0. This becomes even more evident when we actually try to work this particular inequality. That maximum of this quantity. Now mod, the standard thing is that mod of a1 plus mod of b1 is asked, or mod of a1 and mod of b1 are being asked. Then we should always think about mod of a1 plus b1, right? This is a very standard process, right? So what we observe here is maximum of this one, this left hand side, right? In case I want to work this left hand side, maximum of this particular thing is greater than or equal to 1 plus x2 minus x2 plus x3 plus x3 plus 1, right? Whole upon 3. What I have done is maximum of any 3 numbers is greater than or equal to arithmetic mean of those 3 numbers, right? That is what I am working on. So if I work on this particular case, this becomes, all of them cancel out, and this becomes 2 by 3, which clearly gives us the intuition that if a number is larger, that is, instead of n equal to 3 we have n equal to 5 or n equal to 7, then clearly this becomes 2 by 5 and 2 by 7. So lots of students have written answer as 2 by 3 for odd because they have worked for 3 case and they have thought that that would be the final answer, but the answer is 2 by n. And other students who have not used this modulus inequality, what they said was, so the question was asked on n, so 2 by 3 didn't seem that plausible an answer, and moreover the when number of variables becomes larger, there is more degree of freedom, so answer should be in general 2 by n, shouldn't be 2 by 3. That is what intuition they have used, and they have turned out to be correct. Anyways, in case we go for 5 numbers, you can clearly see that this number becomes 5 arithmetic mean, right? So for 7 it becomes 7, so answer becomes 2 by n, 2 by 7. Anyways, using this construction we can clearly see that 2 by n is the answer for Tn, and we can prove that this left hand side, using the same inequality, we can prove that this is greater than or equal to 2 by n, right? And how to construct that 2 by n? We can always go for these things. We can take example of 5 numbers. For 5 numbers, this is 1 plus x2 ka mod, x2 plus x3 ka mod, x3 plus x4 ka mod, x4 plus x5 ka mod, and then x5 plus 1 ka mod. What I did was I tried to go symmetric. So if I have to prove that, now once again, this is greater than or equal to arithmetic mean of these numbers where it will be reached 2 by 5. I guess everybody is understanding this now, using the same construct as this one. Now once again, if you are confused why I went with this plus minus this, I could always write this mod as mod of minus of x2 plus x3, right? Maybe I should have explained that. And so we can simply go ahead with this particular thing, that mod of a plus mod of b plus mod of c is greater than or equal to mod of a plus b plus c. That is what I have essentially used. Anyways, arithmetic mean, this number greater than or equal to 2 by 5. Assuming all that is done, x2, x3 magnitude wise must be smaller than 1. So I am trying to construct a case where they become equal to 2 by 5. Max of this one, hai. So for 2 by 5, what we can do here is 1, I'll keep this as minus 3 by 5, minus 3 by 5, then maybe say plus 1 by 5, this is 1 by 5. Just for symmetric case, it's better to keep that as 1 by 5 because the same thing will happen from the other side as well. We'll keep this as 1 by 5, this is minus 3 by 5, this is 3 by 5, minus 3 by 5, this is plus 1, okay? All right, so we are getting that construct. So we also get a case where we reach 2 by 5 in all the cases. So clearly Tn becomes 2 by 5. All right. So like this was a problem which lots of 11 standard students could have solved in exam time. Wasn't too tough. It's just that when we see question number 3, we suddenly get stuck with that particular idea that question 4 could be even tougher. But as it turns out, question 1 and 4 are of slightly similar level. 4 being slightly tougher than 1, but like out of similar level. 2 and 5 similar, and 3 and 6 are then equally difficult problems. So this is like two papers combined here, where 1, 2, 3 are increasing order of difficulty. Similarly, 4, 5, 6 are in increasing order of difficulty. So 1 and 4, we could have tried these two questions in the exam. Also, question number 2 wasn't too tough. It's just that 2 was slightly on the tricky side. We do not get numbers in the smaller numbers, but most of students have done question number 2. So I guess everybody understands question number 4. And to present this, I'll invite two students here, Abhinav and Yajat. They will come alternately and they will explain solution to this question. Thank you.
So so on the left hand side we have mod of a1 plus a2, mod of a1 plus a3, a2 plus a3, and up to mod of an plus a1. So for even, we can see that if we also we would want that the sign of two consecutive things are like opposite, so that the mod becomes small. So if it's even, then we can keep it like +1 -1 +1 -1, and up to in the end it will be -1. So basically for any two consecutive terms where like an and a1 are also consecutive, we have any two consecutive terms, one is 1 and one is -1. So every term becomes 0, and so we get that Tn is equal to 0. And we can also say Tn equal to 0 is sufficient because the LHS and RHS are both greater than equal to 0. So Tn equal to 0 is sufficient because like we don't treat anything smaller than it. So by this we are easily done for even. This is the easy case. Now is the hard case where n is odd. So like the motivation is that, let us say we want all the terms on the left hand side to be like very small. So if let us say this is like some big number. Let us say this is some x. So this number should have the opposite sign as x, and should also be very close to x. So it is something. Now the next number also should have the opposite sign as this and should be close to this number. So if we keep doing like this, then these two numbers should have also the same sign. So they should be like small, because like if they're big, then they'll add up and become like a big number. So the motivation for this is like, let us say we work for 3 first. So we have two cases. First is when all the 3 are positive or like the same sign, so assume they're positive. So we have a plus b and b plus c and c plus a. So like this is like not working according to us, because we want like some of the numbers to be negative. So assume that like this is positive and these two are negative, and assume like a b c are greater than 0, and suppose b is greater than equal to c. So the two numbers on the left side we have are a minus b, a minus c, and b plus c. So like by symmetry it also feels like these two numbers should be same. So let us say they are like a minus b and minus b. So we will take we have a minus b and 2b. So we will take maximum of these. So let us say b is less than a by 3, then we will take this, and if b is greater than a by 3, then we will take this. So it feels like the best would be to meet in the middle, that is keep b as a by 3 only. So that gives 3 minus 1 and minus 1, and these two, this is 2, this is 2, and this is 2. So we get that it's 2 by 3. Now for 3, if it is 2 by 3, then it feels that for more it should be like less, because like in 3 we have some freedom. So for more a higher end we should have like more freedom. So because for 3 we have 2 by 3, it feels like the answer is 2 by n, and that is indeed true. So basically what we do is we keep the numbers in a circle and we keep it something. So so in 3 we had the highest number is 3. So even in 5, let us say we have that this number is 5. So if we want to, let us say this is the maximum also. So we want this plus this as 2 or minus 2. So if we want this as this as 2, then we'll keep this minus 3 and this also minus 3. And then this one and this one. So we have this as 2, this as 2, this has 2 and this has 2 and this also has 2. So in general we get this construction that if n is equal to 2k plus 1, we can keep one number 2k plus 1, then we can keep it as minus of 2k minus 1, then 2k minus 3 and so on. So basically every time we are decreasing the mod by 2 and every time we are flipping the sign. So every time their sum is either 2 or minus 2. So all these terms are 2 and this is plus minus 1 and this is also plus minus 1. We do the same on this side. So these are either both plus 1 or both minus 1, and in both the case this value is also 2. So we got the construction for 2 by n. Now we prove that the answer can't be less than 2 by n. So suppose there's some t less than 2 by n which works. So assume that this value is the largest and assume this is 2k plus 1 only. And suppose this is ak plus 1. So we can use this property that mod of a plus b is greater than equal to mod a minus mod b. So you get that mod ai plus 1 is greater than equal to mod ai plus 1 minus mod ai. So mod ai is greater than equal to mod ai plus 1 minus mod ai plus 1. So we assume that some t less than 2 by n works. So that means that all these terms of the form mod of a plus 1 are less than 2 because the largest term on the right side is n only. So we assume that this is less than 2. So that means that a mod ai is greater than mod ai plus 1 minus 2, and we know that mod of ak plus 1 is equal to 2k plus 1. So we can easily show by induction that for all I less than equal to k, we have that mod of ai is greater than 2i minus 1. And similarly, we can show in the other direction that this is also true for mod of n plus 1 minus I is greater than 2i minus 1. So we get that all the mods of numbers are greater than 1. Now suppose that now this means that any two consecutive terms should have opposite sign, because if they have same sign then they will combine and the mod will become greater than 2. So they both have different sign. This means that a1 has some sign, a2 has a different sign. Then a3 must have opposite sign as a2, so it has the same sign as a3, and a4 has this sign. So if we go on like this, then we get that a2k plus 1 has also the same sign as these numbers. But this means that a1 and a2k plus 1 have a different sign, have the same sign, but that's a contradiction because like they are consecutive. So we get that t can't be less than 2 by n, so it is 2 by n only.
So tough actually, not that easy, you know. So I don't think it's comparable to question 1, the question number 4. So anyways, the even part was very pretty easy, 0. Odd part, lots of students have gone for 2 by 3 as the answer. So your solution actually tells the motivation why should 2 by n should have been the answer, because if you construct for 3 numbers, we easily feel that the number should be lesser, right? For higher numbers, right? So ठीक and ये is your solution, right? Okay, yeah,
कंस्ट्रक्शन से हिंट ना लेके डायरेक्ट आंसर पे ट्राई किया था.
Okay.
तो उससे डायरेक्ट आंसर देखा.
All right, carry on. Start from beginning only for a resolution.
इवेंट के लिए तो सेम ही था अपने से.
नहीं स्टार्ट कर दो बिगिनिंग से, बिकॉज़ तुम लोग अलग-अलग वीडियो मालूम रहेगा, फिर उसके अकॉर्डिंग में करना है. दो लाइन दो.
क्योंकि ये इनइक्वालिटी जो गिवन है साइक्लिक है, तो विदाउट लॉस ऑफ यूनिटी शुरू में ही मान लेते हैं कि मॉड A1 इज मैक्स. तो फिर व्हेन n इज इवन, we have one construction, say A1 is equal to 1, A2 is equal to -1, and similarly A2i is equal to -1, A2i plus 1 is equal to 1. Last term would be A2n for A2m. For n is equal to 1, we can write n is equal to 2m, which is equal to -1. Hence, all the sums of this mod are 0. While the maximum, which is A1, is 1. So we get Tn is less than equal to 0. And since we need the maximum value of Tn, we can take Tn is equal to 0, which obviously works because these are mod, and mod gives positive or non-zero value, whole value greater than equal to 0. Mod A is greater than equal to 0 by definition of modulus function. So for even, it's obvious that it is Tn is equal to 0 for n even. For n odd, what's the tricky part? My motivation was directly seeing the answer by using some properties in mod, that is mod A plus mod B is greater than equal to mod A plus B, and mod A is equal to mod minus A. Basic properties in modulus function. By using these, we say that first maximum of A1 plus A2, A2 plus A3, A2m plus 1 plus A1. First, as it is maximum, we need to remove this maximum word, because this kind of frustrating us to build the inequality in the basic manners using these properties of modulus function, which we know, which are in our capability. So we say that maximum of these values is greater than equal to the arithmetic mean of these values, because arithmetic mean will eventually lie between the range of these values. So maximum will be bigger or equal to the arithmetic mean. Equality holds when all the values are equal. A2m plus 1 plus A1 by 2m plus 1. Now let us see that some terms cancel out. See A2, A2. It feels like we can cancel out A2 by putting one negative, one positive. And we can do this by this property. So this will be equal to mod A1 plus A2. And let us put the next one negative, minus A2 minus A3. Now we also feels to cancel out that we can cancel this A3. So we will put A3 plus A4. And similarly, we can put the next term negative and last term minus A2m minus 1 plus A2m plus 1 plus A1.
This is what you are trying to cancel out the terms.
Yes, by using the modulus property. This was the motivation. And by using the first property, that mod A plus mod B is greater than equal to mod A plus B, we get that mod of A1 plus A2 minus A2 minus A3 plus A3 plus A4 and so on, minus A2m minus A2m plus 1 plus A2m plus 1 plus A1 upon 2m plus 1 is less than equal to the maximum, which was our LHS by the inequality shown in the last page, and these terms cancel out, which was our motivation in the start. So these leads to the 2a1 upon 2m plus 1. Here is of course 2 by 2m plus 1 mod a1. because this is positive 2. We can get that out of the modulus function, as modulus function it keeps on the sign positive. So we get that Tn is equal to 2 by n for n odd works. Now we have to prove that Tn is equal to 2 by n is maximum. We need construction that this is maximum value of 2 by Tn, 2 by n. So construction के लिए हमने शुरू में कुछ चीज़ें यूज़ की थी कि mod a1 plus a2 mod minus a2 minus a3 and this. All mods are equal because we have used the arithmetic mean. If the maximum value is equal to the arithmetic mean, because for the equality all should be equal. So for maximum to be equal to the arithmetic mean, all the terms in the sequence must be equal. All must be equal. So we need a1, a2, and then in the repeated manner, kind of क्या चाहिए होगा, एक बार सोचते हैं इधर. हाँ, सारे टर्म्स इक्वल होना चाहिए ताकि इक्वलिटी आ जाए. हमको मैक्सिमम प्रूफ करना है. इधर a1 plus a2 आ गया. And let us say that mod a1 is equal to n.
You can take the first number to be sum of all the numbers upon it, right?
We can take the first number as n such that this cancel out and all the terms will be equal to 2 such that this keeps in the integer side, which is easy to build.
Yeah, if all of the numbers are equal, then first number will also be equal to sum of all the numbers.
If first number is
First number will be equal to sum of all numbers upon it.
first
So directly
number
A2 comes out to be equal to A1.
a2 comes out to be equal to
A1, right?
नहीं, एक्चुअली फिर से स्टेप्स रिपीट कर. पहले मैक्सिमम था हमारा mod a1 plus ये दिस. हमने इसको ग्रेटर देन इक्वल टू प्रूफ किया कि वो उसके अरिथमेटिक मीन से तो बड़ा होगा ही मैक्सिमम वैल्यू. एंड उसके अरिथमेटिक मीन में हमने mod a प्लस mod b वाली प्रॉपर्टी का यूज़ करके टर्म्स को कैंसिल आउट करा दिया था. और हमने mod a1 टू tn mod a1 से बड़ा करा दिया था वो LHS को अपने. एंड हमने शुरू में विदाउट लॉस ऑफ जीनियरिटी मान लिया था कि mod a1 इज मैक्सिमम. सो tn इज इक्वल टू 2 by n वर्क्स. तो हमको इसको मैक्सिमम प्रूफ करने के लिए कंस्ट्रक्शन बिल्ड करनी है यूजिंग द इक्वालिटीज विच आर कमिंग इन दिस which we have used in proving tn is equal to 2 by n. So here we have used that maximum is equal to arithmetic mean. So all terms must be equal in this modulus function. And we have also used that mod a plus mod b is greater than equal to mod a plus b. Here equality holds when a and b of same sign. So we need kind of that if a plus b is positive, then the next will be minus a minus b. So minus a minus 2b. We need this kind of construction for tn is equal to 2 by n maximum. And as the maximum value was mod a1, we have assumed, and we keep things in integer side so that our construction is beautifully looking. So if mod a1 is equal to n, then these cancel out and the differences will be equal to 2. So let us take first term n. Then the second one will be 2 minus n, such that this sum is 2. The next will be such that the sum is minus 2. Then it would be n minus 4 and so on 2. So 6 minus n. Let us formalize this by saying that adding two variables x is equal to n and y is equal to n minus 2. Of course x minus y is equal to 2 and which equals to mod y minus x. So let us say the first term is x. The second term is minus y, such that the sum is x minus y. The third term is 2y minus x, such that the sum is y minus x. Then the next term is 2x minus 3y, such that it is x minus y. So here we see a pattern that taking ai is equal to, this is a1, a2, a3, a4. Taking ai is equal to I minus 1 times y times minus 1 to the power I minus 1. See 4 पे 3 आया था और 3 के आगे माइनस था, ऑड के आगे माइनस आ रहा है, तो -1 टू द पावर ऑड आ जाएगा, तो उसके आगे ऑटोमेटिकली माइनस आ जाएगा, और अगर इवन आएगा तो ऑटोमेटिकली प्लस आ जाएगा अपनी कंस्ट्रक्शन में। और अगला i-2 x -1 टू द पावर i-2, ये रख दिया ai को। तो फिर से हर एक टर्म 2 -2 2 -2 ऐसे रिकर्सिवली आ जाएगा। और लास्ट टर्म को हमको चेक करने के लिए कि an प्लस a1 भी 2 आ है कि नहीं, वो हम डाल के देख लेंगे एक बार। an हमारा n ऑड था, तो यह आना है n-1 y माइनस n-2 x, और ये तो हमने x लिया ही था, y हमने लिया n-2, पुट करेंगे n-1 टाइम्स n-2 माइनस n-3 times n, this equals to 2. Hence this is also equals to 2, so the maximum of this is 2, all are equal. This equality satisfies, this equality satisfies, and maximum is 2, which should be greater than equal to Tn times mod a1 n, so Tn is less than equal to 2 by n. 2 by n works and 2 by n is maximum. This is the proof.
Thanks, Shajat. So like beautifully built, nice. So like solution works, and you have nicely used modulus inequality.